Hello everyone. Today we are going to discuss vertical circular motion. Just imagine you tie your mobile phone into a piece of string and move it in a vertical plane. This is called vertical circular motion. Interesting thing about vertical circular motion is speed keeps changing. As it rises up in a gravitational field, speed decreases. When it falls back, speed increases. So we say vertical circular motion is a non-uniform circular motion. So this is a good chance to find out what is a non-uniform circular motion. If the speed is not constant or as v equals r omega, r does not change. So if v changes, omega changes, angular velocity is not constant. Both these two are good definitions for non-uniform circular motion. Now let's check what we are going to learn today. You already know how to define non-uniform circular motion. You should be able to write F equals ma to the bottom, to the middle point and to the top of a vertical circular motion. And there's a speed condition for any object to move in a vertical circular motion. The highest speed at highest point speed should be more than square root gl. You will understand when we get there, okay? First, let's focus on the bottom point. Have a look. Tension is upwards, always towards the center, and mg down. This difference is the net force that will produce you centripetal force. So, centripetal force is normally written as mv squared over r. Here I write mu as the starting speed of the circular motion. Instead of r, I write L, the length of the string. Okay. So from there I can get an equation for the tension. Obviously this tension is bigger than mg because it's mg plus mu squared over L. So if this more let's go forward. Now in middle point tension and mg are 90 degrees. So mg does not help with centripetal force. Only tension can provide centripetal force. So T2, because tension is different now, is mv1 squared over L yv1 because speed also keeps changing. So you can write F equals ma to this middle point or middle height point. And let's think about the most important point, the top point. At the top point, mg and tension both are downwards. They together will provide centripetal force. So from there you can get an equation for tension at the top point. And if you look at these three situations carefully, you should understand tension is highest at the bottom, smaller at medium height, and smallest at the highest point. Tension keeps changing. Make sure you take notes, guys. Now let's try to do a question. They ask what is the tension at this bottom point. They ask, maybe the picture is not very clear, but they ask if the tension is mg or bigger or lower. Of course it is bigger than mg because it is moving in a circular path. Now let's move into a condition for the smallest speed at the top. If you don't rotate your mobile phone fast enough, it will go in a parabolic path and it will fall out of the circular motion. So what is the speed? The condition is the tension of the string should be more than 0. Otherwise it means the string has collapsed or folded. For that you can get the tension equation for the top point. From there we understand speed has to be at least square root g times length of the string. Otherwise it can't go in a circular motion. This is the speed condition at the top for the circular motion. Now in IB, sometimes they don't talk about top point, they talk about the bottom point. That's not a big issue. You write conservation of energy equation for top and bottom, and the height difference is not L, 2L. From there, and you can write that's minimum speed at the top, square root GL. When you put all these things together, have a look. Speed at the bottom should be at least 5 GL square root value. Otherwise, it won't go in a vertical circular motion. And this is all, guys. And our target was to write F equals ma to the top, middle and bottom. and we know the speed conditions at the top and at the bottom, and we have met our targets. And this is more than enough for IB Physics HL. But I have made a separate paper with more vigorous mathematical derivations, and you can have a look. But if you are confused, don't worry about it. What you know already is more than good enough. If you did not write down notes, you can play this video one more time and take notes. Okay. Have a good day, guys. Try SOCOS page 257 one more time. You will understand better. Have a nice day.